Let's talk about z-score some more. Many things have a distribution which looks like this. Heights, weights of 1-pound bags of carrots, body temperatures of healthy people. This is a normal distribution. Mensa is an organization of highly intelligent people. Only people with IQs in the top 2% can be in Mensa. If IQ scores are normally distributed with mean mu equals 100, and the cutoff for joining Mensa is an IQ of 131, can we calculate the standard deviation of IQ scores? Here's the formula for the z-score. Z equals x minus mu over sigma. Here, mu equals 100, and a score of x equals 131 is the 98th percentile. Why the 98th percentile? Well, if you're in the top 2%, that means this area is going to be 0.02, which means that this area to the left is going to be 0.98. So if you're in the top 2%, you're in the 98th percentile. Here's the formula for the z-score. Z equals x minus mu over sigma. Here, mu equals 100, and a score of x equals 131 is in the 98th percentile. But we don't know z or sigma. But we can calculate z. Here's how we're going to do it. Okay, again, you're in the top 2% of scores, which means this is the 98th percentile. This area is going to be 0.98. So we just need to find the score, the z-score that corresponds to this area, the z-score that's to the right of 0.98. Here's another way of putting it. Suppose x is normally distributed with mean mu and standard deviation sigma. On the TI-83, under Dister, inverse norm of c mu sigma tells us the value of x such that the area to the left of it is c. We've seen that before. On the TI-83 under Dister, inverse norm c, so if you don't include the mu and the sigma, that tells us the value of x such that the area to the left of it is c, assuming that x is normally distributed with mean 0 and standard deviation 1. So in other words, if you use inverse norm of c and you don't tell it the mu and the sigma, it's just going to assume, the TI will just assume that the mean is 0 and the standard deviation is 1. And so your normal distribution, it's like the distribution of z-scores. Again, we want to know the z-score such that the area to the left of it is 0.98. So you have this distribution. Area to the left is 0.98. What's the z-score that corresponds to that? So we enter inverse norm of 0.98. Here's what it would look like. So let's see. Let's turn this thing on. Inverse norm, so under Dister, choose inverse norm. Okay, we're just going to choose inverse norm of 0.98. Oops, sorry. Inverse norm of 0.98. Close the parenthesis. And we end up with 2.0537. Let's just round that to 2.054. And we get 2.054. Okay, so z equals x minus mu over sigma. So now we know that x equals 131, mu equals 100, and z equals 2.054. So just plug those in, and this is what we end up with. Now we can solve for sigma. Multiply both sides by sigma, divide both sides by 2.054, and we end up with sigma equals 131 minus 100 over 2.054, which is about 15.09, or the actual answer is 15. The 15.09 just comes from rounding error.